All right, hello, welcome. So we're going to be talking today about the modular monolith. What is this modular monolith? In regards to software architecture choices, there are other choices out there as well. So we'll talk about what those are, why you would use a modular monolith, and if time allows, we'll see some of the code structure for it. So let's get down to business. All right. I have to stress this because I don't think we stress it enough. When you see an architectural style proposed, such as monoliths, such as microservices, in this case, we'll talk about modular monoliths and a couple of the other monolith friends. So what you're going to see is that you'll see an architectural style, you'll be like, oh, this is awesome. This is the hottest, this is the coolest, newest thing. I need to use this on all my projects. And I'm here to tell you, no, don't do that. Don't do that. Each of our software architecture styles has a trade-off. And the modular monolith, I'm going to show you today, you're going to be like, oh, I could see myself using this. But understand it is not a golden hammer. So do not attempt to use this for every project because it might not necessarily be the right choice. Remember, again, with software architecture, everything is a trade-off. So we'll talk about the options that we have in the monolith realm, as well as microservices. We'll talk about those trade-offs. And then hopefully, if time allows, I'll be able to show you the structure of the modular monolith with some stuff from Visual Studio. Okay. Check chat. All right. All right, so when we talk about monolith, and when I say monolithic architecture, it's an architectural style. What I'm talking about specifically, though, is it is a one solution. It is a one distributable set of code. And so think of it as this is how it's organized and this is how it's deployed. With monoliths, you'll see them in the mono repo. Now, I'm going to be very specific when I talk about the types of monoliths so that you understand what I say when I say a particular thing. Let's break it down a bit. So modular monolith is not a legacy monolith. Not all monoliths are the same. And so let's break those down so you understand. Legacy monoliths, this is the grossness that we're probably all dealing with in one form or another. This is that CRUD app that evolved into all these pieces, bits all added on. Sometimes we lovingly call them Frankenstein. Had a few of those I've had to maintain over the past few decades. So rest assured you're not alone. But they're gross. They're a monorepo. It's tightly coupled. This thing relies on this other thing, and if you change one, you could break the entire app. It's you want to scale it? Well, you might be able to throw more resources at it. That might save your problems. But updating and changing and maintaining it, that's going to be slow. It's going to be difficult. You're going to see these kind of things, these anti-patterns, the big ball of mud and spaghetti code, where that code is just so gross, I don't want to maintain it. This is legacy monolith. And so I'll call out the legacy monolith here just so that you're aware that this is usually where we're starting from. It's some kind of gross thing and we're like, how do I upgrade it? Or you're starting from greenfield and you're like, well, how do I avoid this? You don't want spaghetti code. Now, to be fair, you might get lucky. And your legacy monolith might not be as tightly coupled. It might not be as disastrous. Maybe it has layers. Maybe it has like a UI layer, a business logic layer, a data layer. Maybe you're lucky that you've got that. So instead of spaghetti, you got lasagna. Could be lucky. But it's still, it still has its moments. Now I have to give the monoliths credit. Remember, monoliths are an architectural style and they can be done well. They don't have to be legacy disasters. They don't have to be tasty spaghetti code. Not so tasty. So let's see what we can do. Some of you may be like, oh, monoliths. Oh, there's microservices, right? If the monolith doesn't work, we could just move into microservices. So many conferences I went to over the past few years, microservices has been hot. Those sessions have been overflowing with people. Poor Jan here's just like microservices, microservices, microservices. Yeah, Jan, even Marcia got put to the side for microservices. So that's an option, but microservices, so this is the pendulum swinging is how I see that. Where, okay, this isn't working, so let's swing all the way to the other side. We're forgetting that gray area in between. And when I say microservices, this is what I'm talking about. Just so that we're clear on when I say microservices, you know the image I'm painting. So we've got the microservices. Each one of these services can be done and maintained by other teams. This is not in a mono repo. They usually have their own repos. They communicate with an event bus. These could be done in various languages. We don't really care what language they're written in. So you could have a C# microservice. You could have a Java microservice. You could have a Python microservice. Whatever team's responsible for maintaining it, they're going to choose the language that makes sense for them. So this is when you see, you mentioned polyglot friendly. It's because you can use multiple languages. You don't have to be locked down into one. These are individually scalable. And usually if one falls, the rest do not fall. There's that independence, that resilience. So when I say microservices, this is what I'm talking about. This particular screenshot is from eShop on Containers, which is a Microsoft reference app. But on the next slide, for all my Java friends, this is Spring Pet Clinic. So microservices, first of all, it's not just a C# thing, it's all sorts of languages. But then second of all, these are the common examples you're going to see. Now, Martin Fowler, oh, probably very familiar with this one. So his colleagues had said something about you should start a new project with microservices. Notice that this quote comes from Monolith First from 2015. It's almost 10 years ago. We're in 2024 now, so it's been a long time in the making of saying this. Don't start with microservices. Got it so far? Because the thing you're going to hear people say is, okay, so then this modular monolith we're about to look into, we want to start with a simple modular monolith app, right? Inevitably, somebody is going to be like Joey here, Kubernetes. Kubernetes? Kubernetes. Kubernetes microservices, listen, you all, we need to talk. You aren't going to need it. Just because a monolith, and especially if you have a legacy one, and you think that's bad, just wait, there's one more that's worse. But if you've got those and you're like, we need to do better and we need to make it better, swinging all the way to Kubernetes and to microservices, that's overcomplicating things more than you probably need. You probably don't need that yet. And also going straight to those is not advisable when you have a mess on your hands already. So you aren't going to need it. Yeah, just like in this screenshot where you've got the little break in the earth, a little bit of a maybe, I don't even want to call it a stream, but then you have this massive bridge on top of it. You're not going to need it. Even if you think, oh, I'll need it eventually. When is eventually? Are you really going to over-architect now for the future? That's not a good habit to be in. You're not going to need it. So you don't start with microservices. Don't be like Joanne and be like, Kubernetes. No. When I talk about monoliths and microservices, I specifically have this grayscale gradient going from one to the other because it is not all black and white. You don't have to stay at the plain old monolith, but you don't need to go all the way to microservices either. What do we have here in the middle? You're going to hear me call it one of two things. You'll either hear the full name of a modular monolith, or you'll hear me say Modulith. Modulith, again, comes from modular, monolith, or it's just called a modulith. All right. So the characteristics of a modular monolith. You'll see that I use a lot of e-commerce references, and that's because I've worked in e-commerce a lot. And again, with Microsoft with their eShop on web and eShop on containers, we're using references similar to what you would see there. But basically, you'll have different modules. And the ones we're using here are users, cart, orders, inventory, shipping, and reporting. would also do this when I was working in the library space. It'd be users, like the library bag for checkout. You'd look at the circulation in stock, and then for shipping, it'd be whatever that they're checking out. And then reporting is your circulation stats. So that's another way of looking at things. But the modular monolith, so you have these modules, which makes it a little bit easier for separations of concerns. It's a single code base. So your scalability is you're scaling the entire solution. You're not scaling the individual modules. It's not a granular scale. There's some flexibility in there. Now, when you're talking in a modular monolith versus a microservices, with microservices, if you remember, those were individual services. They were talking to an event bus. When you're dealing with the modular monolith, you may not have to deal with that kind of grandiose scale. You can deal with talking with things in process. When you're dealing with things in process, you're not dealing with calls over the network. You can use patterns like mediator pattern, materialized views to get some of the things out of there. The modular monolith, this is a good starting point for applications because it allows you to start with the organization already clean. You're not like, oh, I've got this in this app that's already built and intertwined every which way. Now, starting with this, if you go in with a plan, that's always the case too, is go in with a plan of having these modules broken up and then creating them. So it's a good starting point. The other thing I use modular monoliths for is it's an intermediate step between the regular monolith and the microservices. And I say regular monolith, yes, a modular monolith is still a monolith, but it's a good stepping stone towards microservices. Now, that means what I'm saying here, you're not going to go from a legacy monolith right into microservices. You've got chaos and you've got a lot of like organization and order when it's in the microservices side. So you have to kind of like peel apart that legacy monolith. And how do you do that? Well, that's just a matter of looking through like, okay, what are the different pieces? What are the different modules we actually have here? Well, if you have to go from a legacy monolith to modules, that's why the modular monolith is a good stepping stone, because you're breaking up the chaos and you're finding those modules as needed. I have more slides on how you go from monolith to microservices, so sit tight on that. Now, I want to make sure that we understand with these modular monoliths, when would you want to use them? Greenfield for sure. If you're dealing with a smaller size application, your modular monolith may be your stopping point. Microservices might be too much for what you need, and that's okay. It's good to have a stopping point that's organized and easy to maintain. It's good to have modular monoliths for things where you're able to scale the whole solution. So there's still some scalability there. It's just not the granular scaling each service is needed. If the business solution itself has low complexity, you may just stop at that modular monolith. And let's say you're working with a bunch of developers who have expertise in a stack. Dealing with .NET a lot with our clients, so I may see some teams that are just .NET stack. I have a couple folks I've worked with who are a Java stack, and I have a team that's a Python stack. Go with the language that makes sense for your team. With a modular monolith, though, remember that you're in one solution, and so it's all going to typically be in one language. Now, microservices, those are okay for your larger complex business systems. Again, with them, their strong points are if you want to be able to scale an individual service. So if a particular service has a lot more traffic and needs more resources thrown at it, microservices are great for that because you have that individual, you have that granular scalability. If you have, so we're talking large complex business systems, you're going to have multiple teams with various strengths. So maybe you have something like a fraud detection team, or maybe you have something like a digital rights management encryption team, things like that. Those are very specialized. And maybe they use special languages for their specialty. Well, they can write their microservices in their choice of language. Whereas somebody else, like on the e-commerce side, maybe they're doing like a checkout for, I don't know, ebooks with DRM. Okay, well, what does that look like? Well, then they have whatever language they want to use. So if they want to use C#, fine. And if the backend is Java, that's fine too. Microservices, we don't care what the language is, as long as there's an API to call it. Fault isolation with microservices, the thing to know about that is if one of those microservices goes down, it shouldn't tear down the others. With modular monoliths, different story, because that's all one solution. When one goes down, typically all the others are down with it. Now, told you there's another bad guy. It's not just a legacy monolith. Then there's this guy called the distributed monolith. So I was lucky enough to catch my friend Jay Tower. He was talking about don't build these distributed monoliths. He was presenting that at CodeMash this year. And I was just like, oh no, what is the distributed monolith? Because I've worked with legacy. I've talked about modular before and microservices, but this guy, what is this quadrant? You'll notice that it's got a high number of deployed units and a low level of modularity. So that's already not a good sign. But the best way I describe distributed monoliths is you're trying to take that legacy monolith, you're trying to distribute it, and you really don't have a solid enough background to do it logically and slowly in pieces parts. So you're trying to go directly from legacy to distributed. You see where these pains are going, right? And like the way Jay was talking about it in January at CodeMash, he was talking about how there are these things, and I'm using microservices in quotes because these aren't the microservices we want them to be. So the distributed monolith is still one monorepo. You may have modules, but they may have a shared database. There might be modules with an event without an event bus, so they're talking directly to each other and no mediator. There could be some shared models and not cooperating nicely between them. You have some super chatty microservices where they're talking on an event bus, but they're talking too much and causing way high latency. This tightly coupled services, it's a disaster. Just when you think the legacy monolith is bad enough, distributed monolith, it's worse. It's a lot worse. It causes a lot more tears. So if you saw Steve's appearance a couple days ago with the Visual Studio Live, the Visual Studio Toolbox Live, he had this and he was talking about the different layers talking to each other. And when I saw that, I'm like, this also fits for describing the chaos of the distributed monolith, because when you're talking to different layers and talking to different modules, and then all of a sudden now the modules are talking to each other and to themselves, you don't want this. You don't want it all talking to each other like that. It's pretty gross. So then how do we handle the modulus and how to talk to the modules? Well, use mediator, or you can use materialized views and talk with those rather than talking directly to the modules themselves. So it's a choice. But before we get into the actual layout of the code and how that all works, let's talk about going from this modular monolith towards microservices. So how do you use a modular monolith as that stepping stone? All right, so Strangler Fig is probably one of my favorite migrations and modernization patterns architecturally, more so than a design pattern, because you have this is a middle ground. You're typically going from something like a legacy monolith or the grossest distributed monolith towards microservices. So you settle on a modular monolith, you use your strangler fig, and you end up pulling things out one at a time. You could be pulling out one module at a time. So that's how I like to structure this when you're dealing with modular monoliths, is isolate your modules out one by one. So bring out the users, bring out the shipping, bring out the orders, bring out the reporting, things like that. But don't try to do it all at once. As devs, I know from firsthand experience how many times we've gone into these things early in our careers and are like, yes, let's go, let's refactor this. And then it's just massive overwhelm and it's not orderly. go in with a plan. Strangler Fig, one module at a time. One module at a time. Sometimes you have to take a look and see how things are tightly coupled, what dependencies are in play, because that will help you determine sometimes the order of these migrations. But you want to focus on the services that microservices will give the best ROI. So in this case, focus on the modules. Remember that cost isn't just money. Cost also includes things like dealing with technical debt, dealing with complex systems that shouldn't be as complex, so over complexity, over engineering that shouldn't have been done in the first place, all that stuff. When you're migrating, think of your maintenance costs and your decoupling time. But what's nice when you're using Strangler Fig to go from a modular monolith towards microservices, your modular monolith will shrink over time. And if you're going straight microservices, your monolith is going to disappear. I say if you're going wholly microservices, you may just be going from a legacy monolith to a modular monolith. And so that's still one module at a time. The legacy monolith will get cleaned up, which will be nice. But again, if you're going from the legacy monolith and modular monolith towards microservices, just be aware that you might be in that weird spot where you have new microservices and you still have your monolith. So when you're in a situation like that, add the new features to your microservices. That way it's a lot easier to adapt. All right. So the other thing I mentioned is how do you get things out of your monolith towards microservices? Look for your API layer. That's going to be the thing that you're going to want to pull out. An API layer might be multiple API calls because it might be multiple modules that you start to see. But again, as you're looking at your monolith and the tightly coupledness of it, you need to see, okay, I see a potential users module and I see a potential cart module, for example. But for right now, my cart is on my users and this is really weirdly tightly coupled. How do I break that up? Looking at these things and then determining their order of migration, you might have to migrate one of the other dependencies first. Again, new features will get into the microservices side of things rather than the legacy app. And if you've got specialized development teams, yeah, let them figure out their priorities. Now, let's talk about this modular monolith in terms of what does it look like with modules? What does it look like with organization? Things like that. So with the modules, again, using e-commerce thing very similar to eShop on containers. So these are the different modules that we see here. Users, you have your cart. Remember I mentioned how you could have your cart on your users, and now you're like, this needs to be broken up. So I have different modules and orders, and inventory, shipping, and reporting. And Steve talks about these and had some code to show about that. And we'll show you where you can get that code, how you can sign up to get that. But it's honestly the recipe for e-commerce or any kind of shopping store in general, whether it's you're shopping like a bookstore or if it's shopping like a record store, a music store. A store is a store. So with microservices, these could all be microservices. But as we point out, they're expensive on so many levels. And I have a comparison thing that we'll talk about how those two compare. So know that, yes, you can see your list of modules and go, I could go to microservices. But there are trade-offs. Remember what we said at the very beginning with software architecture. Everything is a trade-off. So what if we could have modules in a monolithic application? When I saw this question, when Steven proposed it, it was just like, why is this even a question? There's nothing telling us that we really can't do this, right? So the modular monolith, you have a host with your various modules. And so the host will know how to deal with the modules. Now, what's good with these modules in the modular monolith? So they are logically separated and independent. They should only be working with themselves. So these guys are not talking to each other. We're not building a distributed monolith. That's not happening. They can be worked on by separate teams. Yes, you can still be in the mono repo and still share your code base with other teams. These are very much feature specific. When it comes to the DDD, so if you're doing domain-driven design, each of these can represent a bounded context. Each of these can be stored differently. So if we go back to the slide where we had the eShop on containers, a few of those had SQL storage, and then it was the basket, or essentially the cart, that would be stored in Redis. So a Redis cache versus SQL storage persistence, they could be stored in different spots. Now, with the modular monolith, they could technically be stored in the same database, but the difference is then they would have their own schemas. So there'd be a user schema, cart schema, orders, and so on, which of course makes it a little bit easier for when you migrate out from the Modulith towards microservices. So having a shared database for a modular monolith isn't necessarily an awful thing. It just means that it has its own schema. Okay. Questions so far? Okay. So the modular monolith code organization I want to talk about in terms of our demo code. We run a website out there right now called Domain Driven Design North America, or DDDNA. And so when we were going through Steve's modular monolith notes, because we all talk about modular monoliths in various forms, one of the things I noticed was that he had these things like he's talking about, I think it's like books and users. And I was like, wait a minute, we can follow the same kind of pattern, only instead of books, we're using user groups. So DDDNA, we track all the different user groups and events that are happening in the domain-driven design space for both North America and then also our virtual that meets within the North America time zones. All right, so let's take a look at our modular monolith and what that would look like. All right, so before we get into the actual Visual Studio code, I want to walk you through the layout of it. So I've got my solution, and then within my solution, I'm going to have folders, solution folders specifically for each module. So for us right now, I have just a user groups module and a users module. Because we list events, I will eventually have an events module. And then we also have room for growth. So we have these different modules, and then we have this web. And the web project then works with the modules. So the web project, if you remember the slide with the host, this is the host with the references to the modules. Now within the modules, so you'll find more projects within each of those module folders. And those, you'll see then things like the actual entity. For the way that I group them, I usually include my tests within the module rather than leaving them separate. And that's just to make sure that we see that, okay, does this module have its tests? Yes, it does. Because testing is something important for us. So we want to make sure we have that. So then what else is going on in these class libraries, for example? So think of Modules as class libraries, because that's what they are. They are logical organization. So within our user groups, you're going to see that we've got repositories, we've got services, we've got our entities, we've got our objects and DTOs, all sorts of things going on within our user groups. In this case, let's go look at the code. All right, let me go ahead and share that. All right, here's the sharing Visual Studio. Let's bring it up. Okay. So what you're seeing here, this is what we're working on for our DDD North America. If we wanted to follow the setup for using a modular monolith. Now, before anybody asks, the code for this is not available at the moment. But I will share a link toward the end where you can get that. Okay. It is Visual Studio. Okay. And what you're seeing here, so this is where the screenshot came from earlier on the slides, where we have our different modules. And you'll see we've got our data. We're using Entity Framework in here. So you're seeing the DB context, you're seeing the repository, things like that. And then you're going to see we've got our endpoints. And so the standard CRUD, the creating, the updating, the getting, the lists, all of that information is here within the endpoints. But we also have our interfaces, and then we have contracts. So I'm going to focus on contracts. And you'll see what we have here. So we have a user group listing. Actually, might make more sense to show what the website looks like, so you know what you have the right context. So let's bring that up instead to show you what is DDD&A, what are we talking about, these user groups and contexts. Great. All right, so there's your DDD&A. And our user groups and context. So this is the events that I was talking about that we aren't going to have code in there for yet, but this is the events. The events, there's user groups. Okay, so with a user group, we have a few things that we like to know. We have a name. In our example code, we'll have a description. We have a location. And then these all have links to various sites. So I could say, okay, DDD Denver, where do they meet? And so you can see DDD Denver, this is their link. One of these I think is, yeah, virtual DDD. So this is their online domain driven design group, is not hosted through Meetup. So it's just a URL. It's nothing fancy. So this is what we're talking about with DDD&A and user groups. And then events are just things like this webinar will be there. The Explore DDD conference coming up in a couple weeks in Denver, that's on there as well. So this is just so you have a visual of the things that we're talking about in the code. Let's switch back to the code. We're back in the code. So when I talk about user groups, that's what we were looking at. So they have their ID, their name, their description, their location, their address. This is what we're talking about for those. we have contracts. So when we talk about contracts, what are we looking at? Well, when I have a query, this is what's going to come back are going to be my user group details. What my user group details looks like. So these are here. These are just your standard contracts. So this is what we're expecting to be working with. These are the expected values to, or not values, but properties that we expect to come back. If you want to see where we refer to them, they're here in a query handler. So we have our query handler. So when we make a query, it's going to do something and then it's going to return. Let's look at this code so you can see what's going on with that. So this is within our user groups namespace, and we've got our call with our contracts. And so we're just like, okay, we have a user group service, and then we want to be able to handle our user group details. The user group details response is what we're going to return as the result from calling it. But what we're going to do is we want to get the user group by its group ID. So if there's nothing coming back, it's not found. Otherwise, we want to return this. So using our query, that is the contract of, okay, what do we have to send for that? Notice for that one, we're just sending the group ID. We're just sending a GUID, and then that's how it'll make the call. And then for the response, it comes back with the GUID that's on there, plus the name, the description, location, website. All right, so with the contracts, you saw that it's referenced there. The handler. And that handler is within our user group. It uses the service. All right, now let's talk about those contracts. So the way the contracts work is those are used to help with the modules so that the modules aren't relying directly on them. So let's say you have two modules, such as in this case, like the user, this example doesn't show it as much, but if you have two modules that need to rely on each other, rather than relying directly to each other, they're going to rely on the contracts. So module A doesn't, so whatever the module is, isn't going to rely directly on the module. It's going to rely on the module's contracts. So best way, I guess, to think about it as I was looking through this is, let's say you have two modules that one depends on the other. You have the interfaces, you have the queries and responses so that those particular modules can rely on their definitions and share it. No, Phil. So the Visual Studio is not being shared at the moment, no. Let me see. So let me go back to this one. Share. Okay. So you should see the slide that shows the solution explorer with user groups module, and then that's expanded and user groups is expanded. You see that? Okay, cool. Thank you. All right. So these contracts, they're here in their own project. So rather than modules, like let's say user groups and users relied on, like let's say users for some reason depended on user groups, they would have contracts, and instead of relying on the user groups, it would rely on the contracts, and then the user groups would implement those contracts. So that's where the contracts come into play. I think Steve does a better job of explaining it as to how those come into play. Steve, are you at a spot that you can chime in?
Yeah, sure. So the main thing with the contracts folder is that it eliminates the direct dependency between any two modules. So if you have, I think in this one, You've
I
got a
don't think,
users module and the user groups module. If users needs to get information about user groups for whatever reason, right? They want some details. They can create a user group details query because that's in the contracts folder and it's public. And then they can use Mediator to send that query. And the handler for that would be most likely in the integrations folder of user groups. And it would handle that. And that handler is an internal class, so it's not exposed. Somebody else can't just new it up, but it can respond to that message. The user groups project then does not have a reference to users or vice versa, right? So essentially what you're trying to avoid is the dependency problem of direct project references between the modules. Because as soon as users depends on user groups with a project reference, there's no way for user groups to ever depend on users. And it's not unusual for modules to need something from a different module and vice versa, right? Or in some circular dependency, which Visual Studio simply does not allow. Now, if you write microservices and you decide that the way you want them to communicate is with direct API calls between them, you end up in pretty much the same problem, except that Visual Studio isn't going to help you out in that case. And the problem I mean is that if user user groups decides it needs some data from users, and they're both microservices, so it calls a get by ID on the other microservice, it has a direct synchronous live dependency on that other microservice being up, which means that they're no longer independent, which means that you're moving toward the distributed monolith anti-pattern that you really don't want. If instead they were both to depend on something that was separate, then you wouldn't have that cross dependency. It's worse with API calls because of latency and a host of other problems with distributed applications versus monoliths. The big thing with a monolith, the nice thing is that everything is in process, so you don't have to worry about that. But you do still have that dependency to be concerned with. And so by using a contracts folder as your public interface, it makes it so that any module can depend on any other module. They only do it by using the contracts, and then the handlers are all still private inside the main library. And you basically have an unwritten rule. You could use some static analysis to enforce it, but the rule is that the module libraries do not depend on one another ever. The web project, which is the host, can depend on them because it has to, because it's gonna load them and exercise their dependencies. But they should never depend on each other. Does that help?
yeah. Thank you.
Yep, no problem.
All right. That's where the contracts come into play. So let's go back and compare the modular monolith and microservices just again to show why would you want to consider modular monolith and why would you want to go forward with microservices. So the modular monolith and the microservices both offer your logical independence. But when it comes to the individual services and their independence, you have that with microservices. So if you need to deal with granular control of your services, microservices is where you're going to head towards, because with the modular monolith, you've still got that one solution deal. When it comes to ease of deployment, though, you're only deploying one thing for the modular monolith, whereas the microservices, you're dealing with the individual services and their deployments. So that's why the ease of deployment's a little more, and it's more gears in this case. When it comes to more gears and more computers and more resources, it's also going to be more costly to host. So microservices are definitely more costly if you do have to go that route. And then when it comes to troubleshooting, when I saw this, when I was doing the research, I can argue for both things. So a modular monolith can be easier to troubleshoot in terms of you're in one solution and it's all right there. But with microservices, when they're done right and they're not talking to each other, you should only have to troubleshoot a single microservice. You shouldn't have to be, well, this microservice needs to rely on that you're starting to look at distributed monolith or gross other coupling things that probably shouldn't be doing. So easy troubleshooting, if the code is not separated nicely, if there is the tight coupling, then yeah, the troubleshooting can get hard. But if it's just a single microservice, it shouldn't be that bad in troubleshooting. I need to stress the granular scalability, because when it comes to modular monoliths, you can throw resources at it. You can throw more memory, you can throw more CPU, but it's all at that one solution. It's not down to the individual service. So if you have a particular service that's getting heavier traffic and heavier demand, you can scale just that service without having to scale all of the services. That's where you have that granularities in microservices. And then when it comes to service availability, like high availability, the modular monolith, you're only dealing with availability for one, versus microservices, you would be dealing with the availability for each one of those services. All right, I see a question in chat. All right, so the question is, in terms of organizing the code for unit tests, do you have different testing projects for unit tests, integration tests for the different modules? And then thinking to group them using solution folders, any recommendations? I'm a fan of folders for organizing things when they make sense. Um, and in this one, it depends, I think, for me personally, and I want to hear Steve as well, is how do you organize your unit tests? So for me, when I do my unit tests, if I can keep those with the module, it just from an organization, easy to find. From where are they stored? Those projects I store in a tests folder. So when I create my solutions, I have a solution file, but I have a source file and a source folder and a test folder. So my source folder is where my class libraries and my web UI and my API, that's where those live. But my tests, they live in the test folder. In the solution, you will have solution folders. You won't necessarily have to see the logical folders underneath. So I use the solution folders to group the modules. For me, I put my unit tests with my module, but integration tests would be in a separate spot because integration is more than just one module.
Hey, yeah, I do basically the same thing. I would put a test folder in each module's solution folder. I do put integration tests in there too, but only if they're like just integrating things within that module. So you're right. If it's
Yeah.
cross module stuff, it would probably go somewhere else and probably someone at the top solution level. But the other thing that I like to do is I'm real big on encapsulation. So I'm going to make sure everything in that module's main library is marked internal if it possibly can be. And that's going to make it difficult for a typical unit test project to be able to get to anything. So you will need to use the internals visible to assembly attribute and just say that the module's internal things should be visible to your, company name.module-name.tests project.
That makes sense, Marco? Awesome.
Yeah, totally. Thank you.
Sure. All right, what other questions do we have?
I have one for you. Why is this not already the default that's used by everyone everywhere? What would you say are the main things that keep people from using this?
I think part of it is because people don't talk about it as much. At least in the circles I've run in, I haven't heard much about the modular monolith prior to this past year. And I think it's just one of those that if you don't talk about it, you're just like, okay, well, what are we stuck with? And starting with a monolith makes sense, but knowing that modular is an option, I don't know why people haven't been starting with it. I mean, for me, an organization thing, I want my code so that it's sorted and easy to maintain, and modular monoliths just make sense. So making these modules before they were even called modular monoliths was something that made sense for me, and that was the approach I would kind of deal with. And especially once we got Mediator, and once we have tools that make it easier for us to do these things and break away from tight coupling of things. I think part of it is there's not an understanding of the tools out there. There's not an understanding of how this all works. But I think that's why we're here, is to do these webinars and do these trainings and create courses on these things so that other people can understand that they have choices and they can make really good choices and make really happy monoliths.
Yeah, one pushback I got about the example that I showed in my course was that it had too many moving parts, too many classes, too many folders, too many projects. And it seemed to them that, any new developer looking at this was just gonna lose it and not have any idea where to even get started. Um, and so imagine in your example that you're showing here that you don't have just two modules, you have, 6 or 8 modules or 10 modules. Now your total number of projects, if each one of those modules has a module and a contracts folder and a tests contracts project, test project, right? 3 things each, and there's
Mhm.
8 or 10 of them. Now you've got like 30 projects plus a web front end, blah blah blah. How would you respond to that?
So I mean, the question comes down to what is the app that you're trying to build? What is the problem you're trying to solve? It goes all the way back to the golden hammer that I showed at the beginning. Is the modular monolith what you need for your solution? Uh, yes, possibly. But what we have here, so you're seeing all different design patterns incorporated in here to help make it a little more manageable and changeable. It does feel like a lot of moving parts, and it is a lot of moving parts at a first glance. Like what I only have one module here because this demo is intentionally supposed to be lighter. Technically 2 modules. I didn't expand the users. But I did that specifically to kind of take away the overwhelm of, oh my goodness, all of these files. Because I think once you understand what's going on with 2 modules and how they can interact, from there, scaling it up, it's not as scary. Yes, it's a lot of files, but they have their purpose, they have their reason. And if you're overwhelmed by this, make use of this thing right here. Close it. Don't have them open for all of your projects and all of your solutions and all of your modules. Don't focus on all the things all at once because that will overwhelm you. Even working with this stuff for 20 plus years later, seeing this amount of CS files, it's overwhelming. And so normally I wouldn't even show you a solution explorer like this because of everything that's going on. And like I followed, so Steve's got this course. I have a couple links here at the end on the modular monolith. There's a getting started course, and then there's a deep dive course, and then they're also available in a bundle. And so when we were looking at his course through DDDNA, I was just like, okay, following the pattern, what does this look like? And so I was like, if I were to rebuild DDDNA as a modular monolith, I would have these different modules. And so that's why I started on that path. And as I built that, I was like, oh, okay, there's our repository, there's our service, there's RTTO, there's QRS. There are reasons for this, and understanding those patterns, I think, makes a world of difference to realize that it doesn't have to be that overwhelming. Sounds like we might need a couple blog posts or maybe a video to show these like in smaller explanations so that
Yeah.
it's a lot more approachable.
And you answered that well, and my answer was kind of along the same lines, which was that when you're focusing on any particular feature or bug fix, you don't care about the rest of it. You care about one module almost always, maybe 2 if it needs to go get some data from another one. And each module should be relatively small, right?
Mhm.
If it's huge, then it could probably be split. And the comparison would be, okay, think of any legacy monolithic app that's had, a team of developers working on it for 5 or 10 or more years. When you go into that, you go look at like the controllers folder and there's 20 or 30 controllers, and you go look at the services folder and there's 20 or 30 services, and
Yeah.
you look at one of the main ones and it's 10,000 lines long. Like, is that somehow supposed to be easier for the new developer? Like, yeah, it's easier to find stuff when everything is in one place, but really? Like I think being able to work in smaller files that only do one thing, if you're
Mhm.
used to that, it's actually much easier to understand what's going on than trying to understand these huge long uh classes or folders full of dozens or hundreds of classes that are all similar uh with no additional organization.
Exactly. Exactly. Honestly, I think it's a way of how you organize it and then how you introduce people to it. And like I said, making use of the ability to close the projects and only focus on the ones you're looking at rather than opening all of them helps a ton.
For sure. And imagine if it was microservices. You probably wouldn't be working on every microservice at once, right? You'd be
No.
working on one. And for modular monoliths, in many cases, there's separate teams working on these different modules. So like your team might only care about that one solution folder. And so the scope of what you have to be worried about is way less than the entire solution.
Right. Right. We talked about the comparison. All right, so monoliths, we're talking like legacy monoliths and the distributed monoliths. Those are logical separation is not there. You usually have tight coupling. Some might have layers, but it's still not enough. Microservices, I know even though we're like almost 10 years out, there's still a hotness to them. Our competition is using them, therefore we must use them. I've heard that before too. Just because somebody else is using them doesn't mean you should. I'll bring out the mom in me on that one. If your competition jumped off a bridge today, would you as well? No, just because they're doing microservices doesn't mean it's right for you. Microservices are more difficult and more expensive to both maintain and to create in general. But that modular monolith, I like how it was Steve who called it the Goldilocks solution. And when I thought about that, I'm like, it is a Three Bear story. I think we need a fairy tale about this. So yeah, the Goldilocks, the modular monolith. That's why when I do that gradient, it's right in the middle. Now, do you go with monolith or microservices? No, that's why I was saying modulith in the middle. And remember, if there's low to no business complexity, this might be where you stop is on the modular monolith. You don't have to go all the way to microservices. If your team has got an expertise in a particular language stack, Modulith is fine. They're much more cost affordable compared to microservices. And modules, again, they could be your stepping stone or they could be a stopping point. Now, as I mentioned, Steve has 2 courses over on Dome Train. So Modular Monolith getting started, that's where you'll see how to create the code and the organization that we were showing. And then the Modular Monolith Deep Dive, he goes further and explores more topics. And you can save 20% off with the code Ardalis. And don't panic if you're like, oh, I don't have this URL. I'll be sending a thank you email here probably tomorrow morning with all these links in them. So we'll have more guidance for you that way as well. Those 2 courses are bundled in a 0 to Hero bundle over on Dome Train. And then if you have any other questions on training, Steve and I would love to do more training opportunities with you all. So feel free to contact us for more training or application and architecture consulting. Next month, so a couple things for next month's webinar. I'll be showing design patterns for testing. So think things like the factory pattern and the object mother pattern. Builder, probably the page object one for front end as well. Those are going to be shown on March 21st. Note that I'm moving things back to 12 o'clock p.m. US time. And the reason I'm doing that is to see if we can get more of our international folks to join us, because I know I've gotten some feedback from some. So we'll try it at 12 o'clock and see. The other thing to note is the US is switching to daylight time on March 10th. So for those outside of the US, just be aware that we will be in GMT -4 for this. We also have the next 2 webinars after that announced. Those are also going to be 12 o'clock p.m. start times, talking about architecture decision records in April. And then in May, we'll be doing an architecture kata together. So that way you can see what is an architecture kata. Get your architectural minds thinking. And depending on time on that, we may also do some architecture decision records for that. So if you're interested in more information, if you need help implementing things like clean architecture or upgrading to .NET 8, if you want us to do training for your dev teams on any of the topics that we've shown in any of the webinars since May 2023, feel free to reach out to us. This contact link, so bit.ly/contact-np. Contact us here at Nimble Pros, and we'd love to work with you on that. So thank you very much.
Thank you, Sarah. Very interesting topic.
Thank you.